What if I told you that there are places in the universe where time stops and space disappears? Yes, you heard that right. The universe, in all its vastness and grandeur, holds secrets that simultaneously bewilder and enthrall us. One such enigma that has captivated scientists and space enthusiasts alike is the mysterious phenomenon of black holes. Black holes, the ultimate cosmic quicksand, are extraordinary and paradoxical entities. Imagine a place so dense that nothing, not even light, the fastest thing in the universe, can escape its gravitational clutches. Yet delve into the heart of a black hole, and you encounter an enigma. It's infinitely empty. This dichotomy is what makes black holes one of the most fascinating subjects of study and exploration in the cosmos. They are like the universe's magic trick, defying our understanding of the laws of physics and challenging our perceptions of reality. They are monstrously destructive, swallowing everything that dares to come too close, yet they are silent, invisible, hiding in the dark corners of the universe. They are the ultimate paradox. The more we learn about them, the more mysterious they become. Black holes are not just astrophysical phenomena, they are philosophical conundrums. They force us to question our understanding of time, space, and the very fabric of the universe. They are cosmic enigmas that tease us with tantalizing hints about the fundamental nature of reality. As we journey together into the abyss of these cosmic behemoths, remember this: black holes are not just distant astronomical curiosities. They are reminders of the universe's profound complexity and the tantalizing mysteries it holds. They are the universe's way of showing us that there's always more to learn, more to discover, and more to understand. Welcome to the enigmatic world of black holes. Hold on tight, because this journey is going to challenge everything you thought you knew about the universe. Prepare to delve into the heart of darkness, where the familiar laws of physics break down and the universe reveals its most profound secrets. Welcome to the enigmatic world of black holes. Our journey begins in the early 20th century with the genius mind of Albert Einstein. A name synonymous with intelligence and innovation, Einstein changed the course of science with his groundbreaking general theory of relativity. This theory, proposed in 1915, painted a fundamentally new picture of gravity. Instead of viewing it as a force, Einstein suggested that it is the warping of space and time by mass and energy that guides the motion of objects, a concept that was as revolutionary as it was perplexing. Now let's fast forward 2 years to 1917, when a brilliant physicist named Carl Schwarzschild began to unravel Einstein's complex equations. Schwarzschild discovered a mathematical solution that described a point in space where gravity is so strong that nothing, not even light, can escape its pull. This boundary later became known as the event horizon, marking the point of no return into a black hole. But the term black hole didn't come into existence until much later. It was the physicist John Archibald Wheeler who coined this term in the mid-1960s. Wheeler's work, along with the contributions of other scientists like Subrahmanyan Chandrasekhar and Roger Penrose, helped solidify the concept of black holes in the scientific community. The discovery of black holes wasn't a single eureka moment. It was a journey, a collective effort over decades that drew from the brilliance of many minds. Each discovery, each equation, and each theory paved the way for the next, like stepping stones leading us deeper into the enigma that is the universe. And thus, the concept of black holes was born, shaking the foundations of our understanding of the universe. A concept so profound, so unimaginable, that it continues to captivate scientists and laymen alike, inspiring us to keep exploring, to keep questioning, and to keep pushing the boundaries of our knowledge. As the 20th century progressed, so did our understanding of these cosmic anomalies. In the early part of the century, the concept of black holes was still a theoretical one, existing only in the realm of mathematical equations derived from Einstein's theory of relativity. However, as technology advanced and our understanding of the cosmos deepened, we began to see evidence of these enigmatic entities through the lens of our telescopes. One of the significant breakthroughs in black hole research came in the 1960s with the discovery of quasars. Short for quasi-stellar radio sources, quasars are extremely bright and distant points of light in the universe, emitting energy equivalent to hundreds of galaxies combined. The immense power of quasars led scientists to speculate that they were powered by supermassive black holes at their centers, marking a crucial step in confirming the existence of black holes. As we moved further into the 20th century, another powerful tool was added to our astronomical arsenal: X-ray astronomy. X-rays, invisible to the naked eye and unable to penetrate Earth's atmosphere, could now be detected by satellites in space. The discovery of X-ray sources in space, notably the first X-ray source in Cygnus X1, provided compelling evidence for the existence of black holes. The X-rays were believed to be produced by matter being sucked into a black hole, producing high-energy light as it spiraled in. The late 20th century also saw the development of computer simulations, allowing scientists to model black holes and their environments accurately. This led to predictions about the behavior of matter near black holes and the appearance of black holes, which could then be tested with observations. From theoretical beginnings in the equations of relativity to the detection of quasars and X-ray sources to computer simulations, our understanding of black holes has come a long way. The progress made in the 20th century not only confirmed the existence of black holes, but also began to uncover their bizarre properties and their role in the cosmos. The 20th century set the stage for a new era of black hole research. With the dawn of the 21st century, we have made unprecedented strides in our understanding of black holes. A wave of scientific innovation and technological advancements has fueled our exploration into these cosmic enigmas. Just 2 decades into the new millennium, in 2019, we made history by achieving the first direct observation of a black hole. The Event Horizon Telescope, a global network of radio telescopes, captured the shadow of a supermassive black hole in the heart of the Messier 87 galaxy, over 53 million light-years away. This groundbreaking image, a fiery ring of glowing gas swirling around a dark core, validated theories and ignited a new era of black hole research. But that's just scratching the surface. Our quest to unravel the mysteries of black holes continues unabated. Scientists around the world are working tirelessly to answer the many unanswered questions. What happens to matter once it crosses the event horizon, the point of no return? Does it get crushed into a singularity, or does it pass into another universe? How do black holes affect the galaxies they inhabit? Research is also underway to understand the role of black holes in the formation of galaxies and the universe itself. Theoretical physicists are grappling with the paradoxes that black holes present to our understanding of quantum mechanics and general relativity. This includes the famed information paradox, which questions whether information can truly be lost in a black hole. The study of black holes has become a melting pot of scientific disciplines, bringing together astrophysicists, quantum physicists, and mathematicians in a collaborative quest for knowledge. These cosmic phenomena are not just areas of darkness. They are windows into the fundamental laws of nature and the very fabric of our universe. While we have come a long way, the journey to fully understand black holes is far from over. Each discovery brings new questions, each answer, a deeper appreciation of the cosmos. As we move forward, black holes continue to challenge, fascinate, and inspire us to push the boundaries of what we know. What does the future hold for our understanding of black holes? As we take strides on this cosmic journey, the future of black hole research promises to be as intriguing as its past. Imagine, if you will, a future where we've perfected the technology to observe black holes up close. We're not there yet, but we're heading in that direction. With the development of more advanced telescopes and detection equipment, we're pushing the boundaries of our observational capabilities. It's likely that in the future, we'll be able to paint a more detailed picture of these mysterious cosmic phenomena. Now let's talk about the potential breakthroughs. One exciting area of research is the study of black hole echoes. These are the remnants of the gravitational waves that black holes create when they collide. By studying these echoes, we could get a glimpse into the very heart of a black hole. This could provide us with unprecedented insights into their nature, and perhaps even challenge our current understanding of physics. Another thrilling prospect is the potential to harness the power of black holes. Yes, you heard it right. Some scientists speculate that in the far future, we might be able to use black holes as a source of energy. This could revolutionize our approach to energy production and consumption, and who knows what other doors it might open. The implications of these advancements are profound. They could reshape our understanding of the universe and our place within it. We might discover that black holes are not just destructive forces of nature, but also creators and sustainers of galaxies. But speculation aside, the reality is that black hole research is a vast, unexplored frontier. Every discovery, every observation, every theory brings us one step closer to understanding these enigmatic entities. It's a journey filled with potential and promise, and we're just at the beginning. One thing is certain: the more we learn about black holes, the more we realize how much there is yet to discover. So, let's keep exploring, keep questioning, and keep pushing the boundaries of our knowledge. Because, in the grand scheme of things, we've only just started to scratch the surface. Black holes, from theoretical predictions to observable realities, they continue to captivate and intrigue us. We began our journey by delving into the enigma of the universe, exploring the infinite cosmos that surrounds us, filled with celestial bodies and phenomena that defy human understanding. Our curiosity led us to the discovery of black holes, a concept that was once merely a theoretical prediction, but has since been confirmed as an observable reality. We traced the evolution of our understanding, from the initial theory proposed by Albert Einstein as part of his general theory of relativity, to the first indirect evidence of black holes through the study of X-ray binaries. These monumental milestones in scientific history not only confirmed the existence of black holes, but also opened the door to a plethora of new questions and mysteries. The modern era has seen significant advancements in our understanding of black holes, thanks to the advent of new technologies and innovative research methodologies. Scientists have been able to delve deeper into the study of black holes, unearthing new information about their structure and behavior, and challenging previously held notions about these fascinating celestial phenomena. Despite the leaps and bounds we've made in our understanding, black holes still hold many secrets. The future of black hole research promises to be exciting and illuminating as scientists around the globe continue to push the boundaries of our knowledge and understanding. As we continue to unravel the mysteries of black holes, we inch ever closer to a more comprehensive understanding of the universe that we inhabit. In the vast expanse of the cosmos, black holes are but one of many mysteries waiting to be unraveled. Their study not only enhances our understanding of the universe, but also fuels our innate human curiosity and thirst for knowledge. They serve as a reminder of the boundless possibilities that exist within the realm of scientific discovery. In the vast expanse of the cosmos, black holes are but one of many mysteries waiting to be unraveled. Stay curious, stay fascinated, and stay tuned for more cosmic journeys.